Okay, let's look at example number 2. A crate weighs 562 newtons. Is resting on a plane inclined 30 degrees above horizontal. Okay, so let's draw a picture of that. So we have 30 degrees above horizontal. Okay. And then we have the crate sitting there. Its weight, or its force due to gravity, is 562 newtons. Okay, it's at rest. Find the components of the weight force that are parallel and perpendicular to the plane. Okay, so what that means is, if here's the plane, right? And then we have some normal force, and that's perpendicular, and here's the x, here's the y. Okay, this would be parallel to the plane, and that would be perpendicular to the plane. So if I'm looking at this force due to gravity, and here's my y, and then here's the x, well, we're on this side of that y there, so our force due to gravity is here. This is 30 degrees. Okay. We know that force due to gravity is 562 newtons. If we figure out the force due to gravity in the x, that's parallel to the plane. And if we find force due to gravity in the y, then that's perpendicular to the plane. Okay, so that's how we can figure out the components of weight force that are parallel and perpendicular to the plane. So force due to gravity in the y, well, that's adjacent to that angle. And so that would be the hypotenuse, 562 newtons, cosine 30. Plug that in. 562 times by the cosine of 30, 487 newtons. Okay? And then we have force due to gravity in the x component, which would be our hypotenuse, our magnitude of the force due to gravity, sine 30. Okay, because it's opposite, that's why we're choosing sine 30. $281 newtons. Okay, that's it. That is the perpendicular and parallel components of gravity to the incline to the plane. Number 3, what is the sum of the forces in the x direction and the y direction for the following free body diagram? Then define the resultant vector for the free body diagram, magnitude and direction. Okay, so let's make the slope our x, okay, and then perpendicular to that slope, the normal force, that's going to be the y. Okay. So I'm going to shift this. I'm going to turn it so that my normal force is pointing up in the y. I did this a lot when I was studying this. I would physically turn the paper and make the y component going up and down to recognize what the new free body diagram would be. Okay. So one moment, I'll worry about that. Let's continue. So we have, I'm going to draw my free body diagram where what I've now called the y, I'm going to say shift that perspective. So we have force normal, then we have force C, what are we, maybe some kind of contact force, That's going up the incline. Okay. And then we have our force due to gravity. But recognize, if this is force C, okay, here's the y-axis, and so our gravity is over here. Okay, so we have our force due to gravity. And remember that this angle is the same as the angle on the incline. So this is going to be 30 degrees. Okay? So what is the sum of the forces in the x direction and the y direction? Or this x and this y. Sum of the forces in the x direction. Okay? So that would be force C, okay, minus the x component of force due to gravity in the x. Now, let's plug in what we know about this. We know that this contact force, or whatever I have going on here, that's 40 newtons. And we're mining this by force due to gravity in the x, right? This x component. And we know that the magnitude of the hypotenuse is 60 newtons. So this would be 60 newtons. We're opposite, so it'll be sine 30. Okay. So I'm just going to plug that in my calculator then. 40 minus 60 times by the sine of 30, which gives us 10 newtons in the x direction. Okay, now let's look at the y. Sum of the forces in the y direction, well, that's going to be force normal minus the force due to gravity in the y. Okay. Force normal is 75 newtons. Minus force due to gravity in the y. So this force due to gravity in the y, it's adjacent. So that's going to be 60 newtons cosine 30. Alright, so we're going to take the 75, subtract 60 times by cosine 30. And that gives us 23 newtons. Okay, let's see if that was everything. What is the sum of the forces in the x direction and the y direction for the following free body diagram? Now we need to define the resultant vector for the free body diagram. Okay, so we have a positive x and a positive y. So if I want to draw another free body diagram, I have longer. Here's the sum of the forces in the x direction. I'm going to add that to the sum of the forces in the y direction. Okay? And then we get a resultant between them, which is just the sum of the forces in general. This is a right angle, so we'll use Pythagorean theorem. Okay? So a squared plus b squared equals c squared, or c is equal to the square root of a squared plus b squared. So I'm going to plug that in. Yeah. So the square root of sum of the forces in the x, which is 10, squared, plus sum of the forces in the y, which is 23, squared. And so the overall resultant vector is 25 newtons. That's the magnitude But now we need the direction component. We need to know what angle we have going on here. Okay, so we're going to use tan inverse of opposite, which is sum of the forces in the y, divided by sum of the forces in the x, the adjacent, and that will tell us tangent. Okay. Y is 23. Okay, so tan inverse of sum of the forces in the y, 23, divided by sum of the forces in the x, 10, and that gives us 66 degrees. Oh, it's because I drew this backwards, so that's my bad. The y component should have been much bigger than the x component there when I drew that picture. So that's why the angle doesn't look quite right. So it would be 66 degrees. Okay, so that's example problem number 3. Okay, number 4, where are we at time-wise? Okay, we have a little bit left on this video. So, a sled slides from rest at the top of a lovely snow-covered hill in Park City. If the hill is inclined at 45 degrees, and the coefficient of kinetic friction between the sled's runners and the snow is 0.18, what is the sled's acceleration? Okay, so let's draw a picture of what's happening here. So here's our incline, 45 degrees. We have our sled, okay, that's going down the slope. Well, what forces would we have acting on this sled? We'd have force due to gravity, force normal, and then we have some small force of friction, right? I'm going to make the incline my x, and then perpendicular to that, which is the normal force, that's going to be my y. Okay? I'm going to redraw this. Force normal in the y, friction in the x, and then to this side of that y-axis, pulling us down the hill, our force due to gravity at a 45-degree angle. Okay, now, if the hill is inclined to 45 degrees, what is the acceleration? Okay, so we set up this problem. Now we need to look at the sum of the forces, but especially in the x direction, because that's where that acceleration is going to be, right? We have the sum of the forces in the x is going to be equal to mass times by that acceleration, okay? And so then when we look at those forces, we can solve for the acceleration. Okay, so when we come back to the last video, we'll look at this example. We'll quickly review our kinematics, and then I'm going to look at one more problem, and then that'll be it.